Hello everyone. This question is related with the seafloor spreading. So this type of questions are asked so many times in the CSIR NET exams, and way of asking is different, but the concept is same for all the things. Okay, and I have already explained those questions in my previous videos, so you can go in the video section and find out from there, and or in the playlist also. So we'll try to visualize the things, okay, not solving this question only, okay, we will try to visualize the things, okay, how why they are preparing this question, and in future what kind of question they will ask from us, okay, because repetition of questions are very less in CSI net exam, okay, concept is same, but way of asking is little different from the questions, okay. So, and always try to make diagram by yourself, okay. So now uh, we are talking about the seafloor spreading. So suppose this is our convection current, okay, and from where our magma is coming and our crust is created here, our oceanic crust is created here, okay, and with the passage of time it is moving away from that, it is moving this way and it is moving this way with some velocity. I'm not talking about the speed. What is the difference between speed versus velocity? Speed is 15 kilometer, suppose 15 kilometer, or in meter 15 meter in a year, in 1 year, in year per year. So here also 15 meter per year, but main difference is we are getting in velocity, we are getting with speed, we are getting direction, okay, in which direction this is occurring. So that's why we are using velocity in our seafloor spreading, okay. Formula is same, like speed is equal to distance upon time. Here velocity is equal to distance upon time. Same thing, okay. So we will use this formula, okay. We will use this formula, okay, to calculate the thing. So now our plate is getting created here. Suppose this is our plate that is getting created here. Suppose this is our plate, okay. Okay, suppose this is our oceanic plate, okay. Now other thing is that during the formation of oceanic plate, okay, at mid-oceanic region, this is our mid-oceanic ridge part, okay, where new plate is created, okay. So here new plate is created, with this sediments are getting deposited in the sea also. If today it is created, okay, there is no sediment on it, it has to settle on it now with the passage of time. So now with the passage of time, this plate is moving this way and this plate is moving this way. If I will construct in 3D, I'm making it in 3D. So now it is moving away from each other, and we are getting sediments on it. We are getting sediments on it. So now with the passage of time, we are getting sediment on it, okay? And it is moving away from with this. Suppose today sediments are here, falling on here. Sediments are continuously falling on the whole layer, okay? On the whole oceanic plate, okay? But here we are having, suppose today it is created, if this part is today it is created, so we are having less thickness sediments here. When this part is moving to this place, okay, so we are getting a layer of this sediment over here. We are getting layer of sediment over here on this oceanic plate. But thickness is maximum here. Thickness is maximum here. As we move toward the mid oceanic ridge, its thickness is getting decrease. The thickness is getting decrease. Okay. So now we are talking. Now I will zoom this part. Okay. I will zoom this part. Why I am zooming this part? Because question is related with this. Okay. Suppose this is our sediments that are got deposit. Just mention what kind of sediments are these. Okay, I will add one more question. Okay. Okay. My question is option A. Pelagic sediments. Option B. Silica clastic sediments. Okay. And option C is irregularia. D is chert. Okay. And E is, option E is carbonate. Carbonate and evaporite. Deposits. Sediments. Okay. Sediment rock anything. Okay. So now you have to tell me this, okay? What these sediments are from this option. This question is multi-option question, okay? Multi-option. You have to select multi-options, okay? Try this question, okay? Now coming back to our question. So this is the sediments that are deposited on the ocean floor, okay? And with and it is how much it is away from that? It is how much? 200 kilometer. Okay, 200 kilometer. Two kilometer away from the mid oceanic ridge, okay? And we are getting sediment on it. This place we are taking this part, okay? Same way, okay? And we are now zooming it, okay? And here we will get sediments. Okay, this whole sequence is not forming at this single place. Okay, here itself. Initially, this part is at this part, and with the passage of time, this part is moving away from the mid-ocean. It reached 200 kilometers away from the mid-oceanic region now. So they are telling the sediments that are deposited. Question is the thickness of the sorry. Question is thickness of the sediments on the sea floor at a place 200 kilometer away from the spreading center is 200 meter, 250 meter. The thickness of this means height or thickness is how much? Is 250 meter. Okay, and if sedimentation rate in the area is 5 centimeter per 10 to the raised power 3 year, and how these sediments are got deposited? Okay, these sediments are deposited with the speed of with the sedimentation rate of 5 centimeter per 10 to the raised power 3 year. Okay, so our answer, and we have to find out what the rate of sea floor spreading is, how much these plates are moving away from, with which velocity they are moving away from each other. We have to calculate that one, and for that we need what? We need velocity, distance, and time. These things we need now. Okay, we have distance. Okay, we don't have velocity or time. Okay, so we have to calculate velocity. For that we need time, and from where we will get our time? We will get our time from this. Okay, we will get our time from this package, that sedimentation rate. Okay, that sediments that got deposited on the, from that we will get our this thing. Okay, this is thickness. Okay, so how we will get that? As we know that, we'll remove this part. Okay, now as we know that this 5, I will tell you by formula also we can calculate, by this we also we can calculate. Okay, this is given to us now. Sedimentation rate is equal to this much. Now for 10 to the raised power 3 means for 1000 year, sediment rate is how much? How much sediments are got thick? 5 centimeter. Okay, and our question is within, answer is within centimeter, so we will convert this meter into centimeter, this kilometer into centimeter also. Okay, so next step is, this is 250 meter, this height is 250 meter na meter. Okay, so we will convert it into centimeter. Okay, 250 into 100, so we will get this. This is our total thickness for depositing 5 centimeter thickness. This much year it will take. Okay, to calculate this much. Okay, how we will calculate? If we multiply 5 with 5, 5 with 5 will get how much? We will get 25. We will get 25, and how many zeros we need? 3. Okay, okay, and same way if I multiply this side with this number, okay, to make it this number. Okay, so similarly we have to multiply this side also. 1000 into how many zeros? That is important. Okay, so now this side we are getting about 2500 centimeter, and how much time it will take? It take 5 into 3 and 3 6, Okay. Now we are calculating the time to deposit this much. Okay. Time we have now. We will use this formula. We have to calculate the rate now. This velocity. The rate of sea floor spreading is distance. Distance is 200 kilometer. So we will multiply it with the first 1000. We are making meter. Now in centimeter we have to convert. Because our answer is in centimeter. Okay. Divided by this. Because we are calculating rate of sea floor spreading. So now it is 5 into 10 to the raised power 6. So these are getting cancelled. Okay, 5 4. So we are getting 4 centimeter per year is our answer. Okay, we are talking about one side. Okay, in one question they are talking about how much spreading. In that case, okay, they are asking about the both the plates. Okay, so then we multiply this number with 2. Okay, total spreading rate is 8. This plate is moving 4 centimeter per year, and this plate is also moving 4 centimeter. Okay, total. So hope you learned something from this video. Share this video with your friends so that they can also get benefit. Ask question from the system from wherever you are learning. Don't wait for the opportunity. Be ready. Thank you.